Okay, we're going to be looking at reflections. So let's consider, I'm going to need to change the colour on my pen or we won't see a thing. Let's consider this graph, y equals x squared minus 2x plus 1. And we're going to do a wee sketch of that, see what it looks like. Do it here, like that, and it will be something like that, and that'll be about, this will be 1 here. Now let's consider, I'm going to actually change the colour of the pen for the second part of it. Let's put that in green, hopefully it'll show up nicely. Y equals minus, I'll put this in brackets, x squared minus 2x plus 1. So this will be a reflection in the x-axis. So when the x coordinates are the same, so x is the same as x, the y coordinates are flipped, so y equals minus y. So you have that reflection in the x-axis. Hence, y equals x squared minus 2x plus 1 is a reflection of y equals minus x squared minus 2x plus 1. The general rule would be the graph of y equals f of x is a reflection of the graph of y equals minus it is a reflection of y equals f of x. Yeah, there's a minus in there. Now let's consider a reflection in the y-axis. Of that, and so let's consider y equals x squared minus 2x plus 1 again. So it's the same graph that we're doing. So let's do, and that's 1. Now let's consider in blue this time. Consider y equals, now this time we're going to take x and we're going to make it negative. All x is negative. Minus x squared minus 2 minus x plus 1. So in this one, x is replaced by minus x, and this is going to be, so minus 1's here, here. So it's like if you were to, it's reflected in the y-axis. So this is y equals minus x squared minus 2 minus x plus 1 here. So the curves are at, so we have here, when x is replaced by minus x, y equals the y in blue. So the values of y are the same when you take x and change it to minus x. So the general rule here is the graph of y equals f of minus x is a reflection of the graph y equals f of x in the y axis. Okay, we're going to look at an example of this in practice. So, the quadratic graph y equals f of x has a minimum at 5 minus 7. Find the coordinates excuse the bad writing. Find the coordinates of the vertex and state whether it is a maximum or minimum of the graph for each of the following. So y equals minus f of x and y equals f of minus x. So I'm going to just put a line down here and we'll deal with them both separately. So this here is a reflection of f of x in the x-axis. The turning point is, so let's look at the, for f of x, the function had f of 5 minus 7, so 5 is going to be the same, because in a reflection on the x-axis, the x remains the same, but the y is going to change sign, so it's now going to be 7. So this is a maximum. Now for this one, this is a reflection in the y-axis of f of x. So the turning point here, the term turning point is a generic term for anything that's a maximum or a minimum. You can just say it's for any time in the quadratic curve where there is a turn in the direction of that curve. So you can use the word turning point if you're not sure if you're talking about maximums or minimums. So the turning point here, so in the when it's a reflection in the y-axis, the x-coordinate is going to change, but the y-coordinate stays the same. So this is a minimum. And when if you think about the graph we drew earlier, it's going to the graph would in the x-axis, you're going to have that reflection, so that would flip the turning point from the minimum of f of x to a maximum in minus f of x. So I hope that helps.